Panomba twalalolesha pali operation ya crusher so that tukwate complete view, because twadalolesha last time pama conveyor belts, and then we made a brief mention of the crusher and then the vibrators, of course. Now, seeing as how they are part of that process, twalabula ayama schematics for the crusher, of course, and then the vibrators, so that we have one complete system from the beginning to the end. Napakwamba ilo tatulashite fili fyonse twalashita map ama inputs nama outputs. Now, of course, kula bama ways ayengia kuchitila mwevi. What we're going to do is not just the only way this can be done, so you have to bear that in mind. But my personal preference is what I'll show you. Okay, so apa tulelolesha padi crusher lubrication control. Of course, there's also the main drive. Okay, there's the crusher main drive control, and then there's the crusher hydrostate control, and of course there's the crusher vibrator control. Now, pakwamba, we're not going to talk about the hydrostate, the crusher hydrostate control, and we're not even going to talk about the crusher vibrator control. Tuwala ishitafe limit kudi crusher lubrication control na crusher main drive control, because aya yadiba dependent. Okay, nangula intile the operation ya crusher, this crusher main drive, okay, is dependent on the operation of the crusher lubrication control. So pakwamba, we just focus on the crusher lubrication control, and then of course we've also do the crusher main drive control. So let's now just map the inputs and the outputs. As always, we're going to have to create a name for our project. Okay, so we're just going to say, when this step 7 wizard, new project wizard comes up, so we just call like next, and then of course we're being asked the CPU that we want to use. Apama CPUs yengi, I mean, what determines which CPU you are going to pick eventually is going to be determined by the hardware that you have. But seeing as how efforta tukwete hardware iliyonse, and my personal preference is just the CPU 3152DP. Now, in this interface, we're being asked to say what's the name that we want to associate in a CPU. And because I know the project, we're going to call just plant 004. So I'm going to call this CPU as plant 004. And then the multi-point interface address, we'll just leave it as default. We'll go to next. And then the language, of course, because it's better we stick to ladder logic. Of course, statement list, no functional block diagram, but in this particular case, to ladder. And then, of course, the preloaded organization of blocks, to allow choosing a OB1 for now, because we don't have any need for these other ones. And then we'll go like next. What's the name of this project name? Again, same as the CPU name. I think that's plant 004. And then we'll go like finish. Now, when this opens up, I know there's a whole lot of things we can do, but for now, my only interest is in this symbols list, or this symbols file, because that's what I wanted to show you. So we're not going to do anything in here, but we're just going to open the symbols list, or rather this file here. Okay, and because of what we're about to do, or what we're going to do later, there's something we're just going to do. We're going to just enter arbitrary addresses for Boolean inputs, and then for timers. So this first Boolean input, I'm just going to call x1, and I want this to be a Boolean data type, or rather first address, memory bit 9.0, and then of course it's a Boolean data type. And then for a timer, I'm going to just call T100, the terminator 100. and then this is going to be T9 because all the inputs and the timers are usually just start from 10. Okay, and then of course this is actually a timer, and then I'm going to save this. Then having saved this, these are just arbitrary addresses which have actually no significance except for showing us how we're going to be inputting the addresses when we export this list. Okay, so what we're going to do is we're going to go like symbol export. Okay, and then I'll just have to put this on the desktop. Okay, I'll choose the desktop like so, and then I'm going to call this. If you notice, I'm being asked to choose the data type format. Okay, now the default, there are several other ones like ASCII format, there's assignment list, there's data interchange format, there's system data format, there's all right, but yotulefwa hapa niibalela ndati data interchange format. And then this one, the list for this symbol table, we're just going to call it plant 004, and then we're going to save on the desktop. And then of course we're going to close this. And then having done this, we're going to now open up the Excel. Okay, we're going to open up Excel. And then when Excel does open up, we're going to open that list we just created. Okay, so open, we're going to go to the desktop, and then I need to pick all files. And then the one I want is plant 004. Then of course it's going to open like this. Okay, so when it does open like this, or maybe just so we move at the same pace, maybe there's something we could also have done. Okay, we could have done just one other thing. So let me just close this again. I'm not going to save. I'm going to go back to the symbol table, and I'm going to enter some symbolic comments. Okay, so we're going to call timer. I'm going to call this as timer. Timer 100, because it really doesn't matter much. Okay, then input 001. Don't bother about the comments. Okay, it's just so it's easy for us to understand. Again, export. We're going to save it as that same file. Then we're going to say save, yes, overwrite, then close. Then let's go to Excel once more. Okay, Excel opens up. We're going to say open, and then of course it's on the desktop. Okay, I need to open all files, not just Excel files. I'm going to open this right up again. So this is what I wanted to show you, that even the symbolic comments are important. We're going to start with the crusher lubrication control, deal with the output coils first. Okay, so with output coils, what we're going to have is in the first rung, which is number 3, we've got this output coil, or relay coil if you want, which is designated as 3BD6. So this is actually the explanation for this coil. Okay, I'm just really going to refer to them as coils because they're associated with either relays or power contactors. Okay, so 3BD6 is a designated safety relay, and the reason why that is because if you look at the nature of the controlling conditions, okay, I'm just going to call them conditions in the sense that you notice that this one, E, Bale system emergency stop, then the other one system emergency stop, then the other one crusher emergency stop, then the last one is like the emergency stop. Now you notice that my emergency stop now fuller. Reason being that if this was an actual plant, which it is, it has got so many IAMA emergency stop push patterns at different locations in the same plant. Okay, so we'll go like 3BD6. We're going to go like 3BD6. Okay, 3BD6, which is this one here. Okay, this is 3BD6, and the address for all the outputs. I'm going to start with memory bit address 100 for output coils. Okay, 100.0, And then the data type, of course, is Boolean. Okay. The symbolic comment, this they're calling a safety relay. I'm not doing anything different. I'm just getting this comment here. Okay. So this right here is a safety relay. And then the next coil is 3BD1, then 3BD2. Okay. So let's just drag this down. We know there's 3BD1. And then, of course, there's going to be 3BD2. And then the addresses we just drag down. Okay, so now you see the convenience of having to export our symbolic list, or rather the symbol table, into Excel. Okay, so now we have these, and then of course the data type is all Boolean. 3BD1 is being designated as a sequence control relay. Okay, sequence control relay in the sense that E3BD1 is the one which initiates the whole process of starting the system, inclusive of the lubrication system and the main drive, the crusher main drive motor itself. So 3BD1 designated sequence control, designated sequence control relay. Okay, and then 3BD2 is a designation, it's a timer actually. So 3BD2 is a timer, and what we're going to do is, this is going to be in two parts. Okay, because we're going to need the auxiliary context of this timer designation 3BD2 to be used as an interlock in, let's say for instance, network 10 or rank 10. 3BD2 is used at this position, or rather in this position. So I'm going to just return 3BD2, and then in this particular case I'm going to think of it as having an associated output coil. So what I will do as a placeholder for this timer, I'm going to also need a timer. Okay, so maybe let me just put it there, and then we're going to start with timer 10. Okay, and then we're going to say 3BD2. We're going to say 3BD2, and then I assume this is an off delay timer. So no, it's an on delay timer. Okay, so 3BD2 as a lubrication control timer is an on delay timer. And the reason why this has to be an on delay timer is because of the way it's been used. Okay, you notice that, don't worry about what these conditions are, right? If you have a continuity between this point 3B1 and 3B10, like all these conditions have been met, and then you press the start, you notice that the instant you press the start push button, or rather the system start, you're going to seal in through this auxiliary contact for 3BD1 in this position. Okay, so once you seal in, at that point this timer is also energized. Okay, is also energized, and if you notice that 3BD2 is used in this condition, in this position here for the clutch timer. So what's going to happen is the system control relay latches, this timer is energized. Okay, at the instant that we're energizing the sequence control relay, this contact is going to close because it's normally open, so it's going to close when 3BD1 is energized. The normally open contact is going to close, and then the alarms in both the local station and the remote station are going to be energized. So meaning you have that pre-start warning alarm, right? And then as for 3BD2, it's going to give the pre-start warning signal enough time before it actually allows the lubrication system to be energized. Okay, because once 3BD2 timer, the preset time value elapses as an on delay timer, it's going to then close this position here, and then the clutch timer Nishiaba energized, and then in that instance the lubrication pump is going to be energized. Okay, don't worry about this ICIO, because in the original schematic, okay, the original electrical control system, what the clutch timer does essentially is this ICIO contact prevents this coil from being energized. It prevents 4DC1 from being energized the instant you have power at this position, in this position, like 4D6, okay? Meaning if this auxiliary contact is closed, all these conditions are healthy, 3BD6 is also closed, and then you are in the normal position, you're going to have power at this position, okay? Now, because you have power in this position, if this contact wasn't there, then of course 4DC1 would just be energized and the lubrication pump would be brought online, which is what you don't want, okay? You want that to be controlled through 3BD2. So only when 3BD2 is closed through the timer 3BD2, then this is going to close, then the clutch timer will be energized. The instant the clutch timer is energized, this contact designation ICIO is going to instantly close, and then of course the lubrication pump will come on, okay? Now, at the point where you are switching off the system, the normal system stop, what's going to happen is 3BD2 is going to be opened, okay? Because in this position here, you press the system stop, 3BD2 is de-energized, its normally open contact opens, meaning this position opens, right? Now, because of the design of the clutch timer, the lubrication pump will keep on running up until the preset time value, as set between 0 to 6 minutes elapses, and then in that state, ICIO is going to open, and then the lubrication pump will stop, okay? So that accounts for 3BD2. So 3BD2, we're calling it an on-delay timer, and then the associated contact, okay? So this, we're going to call lubrication pump control timer, okay, like so. And then this 3BD2 is going to be associated with this timer, okay? That's the relationship between this timer and this designated 3BD2, because we just need to have all the associated auxiliary contacts of this timer, the digital implementation associated with 3BD2, okay? So now we have that. So we've taken care of the loop control timer. And then the other one would be the pre-start warning alarms in the local station as represented by alarm 1, and in the remote station as represented by RR. Okay, so these we can just say pre-start warning, siren, and then local, okay, or rather just LS, okay, LS, and then the other one will be RS, okay. Then of course these are just output coils. They are Boolean data types. So the first one will be the pre-start warning siren, which is in the local station, okay. Local station, and then of course we just drag this down, pre-start warning siren, and then this is going to be remote station, okay. So what just means is you have two pre-start warning alarms, one in the local station, one in the remote station, okay. So we have these two dealt with, okay. Then of course we need a timer as a representation for this clutch timer, okay. So we need a timer. So what are we going to call this one? Out of respect for what the clutch timer is, we're just going to call this as clutch timer, okay. We're just going to call this as clutch timer. And I don't want to have to deal with spaces in the symbolic table, so clutch timer. This is going to be T11. It's going to be a timer. And then, of course, clutch timer is clutch timer, so we don't need the symbolic or comment. Okay. So the only other thing is 4DD3 as associated with a clutch timer is used in several other points. Okay. So in the same way, we're going to associate 4DD3 to an output coil. Okay. So we're going to have 4DD3 as an associated auxiliary contact of this timer. Okay, so we're going to just say 4DD3. Of course, it's a Boolean data type. And then we know that, okay, for the symbolic comment, we're going to just say clutch timer associated output. Okay. Okay, so meaning when we look at 4DD3, we know that its condition can only be as a result of this clutch timer. Okay, so the semantic implementation of this timer is going to be done for the clutch timer, and then the output of this timer, we're going to associate it to 4DD3, which takes care of this output coil. Okay, and then the other one, number, will be the lubrication pump coil. Okay, which is this one here. So this is going to be 4DC1. It's an output coil and it's Boolean, so the addresses just flow like that. And then this will be lubrication pump control relay. Okay, or lubrication pump control. Maybe we just leave it at lubrication pump control. We know we are talking about the control of that power contactor for the lubrication pump, okay, which takes care of 4DC1. And then going on, we'll come across the main drive delay timer. Clearly, this is an on delay timer, so we need another timer. And then this one, we just call it main drive on delay timer. Okay. So symbolic comment main drive delay timer, like so. It takes care of this one here, main drive delay timer, as this timer here. Okay. Or maybe it's better, or we just maybe put a dash then what? Then 4DD2, so that we remind ourselves of the association. Maybe clutch timer. Maybe we'll also do the same thing with this one here, so that we know the association between these. Okay. So we're just saying this is the main drive delay timer. Okay, and it's associated with 4DD2. Okay, and then of course as an output coil. Okay. As an output coil, we have 4DD2. We're going to get 4DD2. We're going to put it right there. It's Boolean memory bit address 100.7. Okay. And then that's about it. Are we good? So 4DD2. The reason I'm doing it like this is so we know to relate whenever we talk about the main drive delay timer, we're just trying to say that the associated output is 4DD2, so that we're just able to use this output wherever it is we want to use it. Okay, this is just one way of doing it. So Tuabula 4DD2, and then thereafter we are talking about 4DD1, okay, which is also an output coil. And then this is a 4-strip auxiliary relay. Okay, so we come here, and then we're going to call this as 4DD1. 4DD1, of course, memory bit address 101.0, it's Boolean, and then 4DD1, we're going to say lubrication pump, lubrication pump, lubrication pump fourth trip. Okay, lubrication pump fourth. Okay, lubrication pump fourth, or maybe we just call it lubrication pump status. Okay, status as it is in faulted. Okay, we're talking about faulted or healthy. Okay, now we would assume just by looking at this that the state of this output coil, or rather this coil, is supposed to be de-energized, because all of these in Gamalolesha 4DE3, 3BD5, then 4DE2, these should never close, because once any of these closes, okay, if this one closes, it initiates this to be energized, and then it's going to seal in through this auxiliary contact 4DD1, and then the system will be in a faulted state. That's why I'm saying 4DD1, this 4DD1 is basically a lubrication pump status, whether it's in a faulted state or healthy. Okay, and then right across from this fault strip auxiliary relay, that and that fault indicator. Okay, so we can just insert then 4DH1, they're calling it 4DH1. So when this indicator lamp comes on, you know the lubrication pump is in a faulted state. So we're just going to say lubrication pump fault, because once that the lamp, once this lamp comes on, you know the lubrication pump has a fault, whether could be thermal overload, or could be earth leakage relay, or maybe there's no flow in the system after the designated time. So that's how come that quite a 3BD5. Okay, 3BD5 is just an indication of the flow. Okay, in case you're wondering, oh, where am I getting this? So it's this one here. Okay, this is 3BD5. 3BD5 lubrication oil failure relay. Okay, we've got this relay here, and then let's see, 3BD5, we're talking about 3BD4. Okay, we're talking about 3BD4, and 3BD4 has to do with the flow. Okay, so lubrication oil flow switch 1, lubrication oil flow switch 2, meaning these are supposed to close. When these close, 3BD4 is energized, its auxiliary contact opens this position, meaning 3BD5 under normal operating conditions is never supposed to be energized. So once 3BD5 is energized, then because 3BD5 is energized, then you're going to have an issue right about here. Okay, so 3BD5 energized, you're going to have, and assuming this condition is true, like it's closed there, you're going to have this flow of power. Okay, all the way to 4DD1, and then 4DD1 is the fault strip auxiliary relay. It becomes energized, your system is faulted. Okay, and the lamp comes on. So that's about it. Then 4DH1, we're saying lubrication pump status faulted indication. Okay, it's an indication. So then the other indicator lamp is this one, the designation 4DH2, and then they're saying that lube oil pump running. Okay, so I'm going to squeeze in right after in this position here, and then this they're calling 4DH2. Okay, everything is true. Let me just drag down everything. So this is 4DH2, this is 4DH2, memory bit address 101.2, it's a Boolean data type, and then of course lubrication pump status running. Okay, like so, because they're saying lube oil pump running. So like now, right about now, we've dealt with yes please. No, don't worry about this. I'm just being asked to say the plant 004 data interchange file or format may contain features that are not compatible with DIF data interchange format. Do you want to keep the workbook in this format? To keep this format, which leaves out any incompatible features, click yes. So which is what I want to do, okay? Because I just need to retain the status of this file. So to apwisha yonsayama output coils. So now we go to the other part. I could have gone to the main drive and just gotten the output coils, but for now, let's stick to the crusher lubrication control, and then let's look at the input conditions, which are not associated with any output coil. Okay, so in the first rung, designation 3, you notice that we've got my emergency push buttons, system emergency stop in this position, stay put lockable, then system emergency stops, stay put lockable, crusher emergency stop, stay put lockable, emergency stop. So we've got 1, 2, 3, 4 emergency push buttons. Okay, so what we're going to do is this. We're going to associate a set of addresses. Now my emergency push buttons, these are system protection related. Okay, system protection in the sense that I'm thinking of those conditions which are like not normal conditions. If there's an emergency situation which warrants you to stop the system, then I have my emergency stop push button. So what we're going to do is anything that is remotely related to the protection of the system will associate a unique address. Okay, so to attach that, so as inputs. So where do we put them? Okay, because there will be a low address, so maybe I will just need to insert them right about here. Need to insert a whole lot of them. Okay, so okay, how do we? Okay, we're just going to call station 1, station 001, emergency. Okay, EMR. Okay, so there are 1, 2, 3, 4. Station 1, emergency stop. Okay, EMR STP for stop. Let me just drag them down, and then I'm going to call this other one as station 2, this other one as station 3, this other one as station 4. Okay, the addresses for safety inputs for the lubrication pump, we can start from, okay, I don't want to create any drama eventually, so I'm just going to copy this so that I avoid any unnecessary problems. So 20.0, and then of course these addresses are going to be like so. The data type is of course going to be Boolean. It's going to be Boolean data type. And then the symbolic comment. So okay, we can say station 1, emergency stop. And then hopefully if I drag them down, and this other one is going to be station 2, station 3, station 4. Okay, now I haven't done anything unique in the sense that I'm just going to think of this system emergency stop in this position as station 1, station 2, station 3, and then station 4, regardless of the location they are in, because later on we can have these emergency push buttons assigned to any location you so choose. Okay, and okay, so this takes care of the inputs. These are discrete inputs, the emergency inputs. So we've got this one here, this one there, this one there, this one there. I don't know what NDR is, and I'm really relay. I don't know what this is because there's no mention of what NDR is. So we can just forego the implementation of this. And then if we move on to the second rung for the sequence control relay, let's see, 3BD5 is conditional, 283 is conditional, 3BD3 is conditional. I think these are all conditional. I'm saying conditional in the sense that, for instance, 3BD5 is associated with a coil, as we just previously looked at. So is 283. You notice that 283 is in the main drive. Okay, 283 should be right about here. Okay, it's an output coil, and then the output coil has got auxiliary contacts, which are then used in this position for 283. Right about there. So that's why I'm not even bothering with having to assign these inputs, because already they are assigned somewhere. Okay, they will be assigned eventually. So we're down here, we come conditional, conditional, conditional. So the system stop and the system start, these are discrete inputs. Okay, these need to come from outside the system. Okay, so for normal inputs, okay, let me just insert here. Insert again. Okay, so we're going to have the system. Okay, we're going to have the system start. Okay, memory bit address. Okay, let me just borrow this, paste there. For the normal inputs, we'll start with memory bit 10.0. And then this other one, okay, let's drag and drop. Let's drag, slide down. So the other one will be system stop. No need for symbolic comments because, I mean, these are self-explanatory. Okay. And then, so we've taken care of the system stop, and then we've taken care of the system start. So these two are taken care of. Okay, all the inputs, discrete inputs. Okay, then moving forward, what else do we need? Okay, let's move to rung 10. With rung 10, we're talking about the MC auxiliary contact. Now, MC was the power circuit. Okay, so MC, main circuit breaker for the main drive, has auxiliary contacts. Okay, which are being referenced in this position. Okay, so as an input, as a discrete input, we can just say MC what? MC 01. Okay, and the reason, ladies and gentlemen, I'm going to put this MC 01 because I know it's supposed to be a normally open contact. So main drives, no, that's not main drives, but main drive circuit breaker. So normally open, auxiliary, okay, auxiliary contact, okay, like so. That's why I'm putting this -01. I'm going to think of anything I see with a -01 as normally open, anything with a -02 as a normally closed. Okay, so that's about it in relation to this. I'm just trying to point out the fact that this has to be used as a normally open contact from the main drive circuit breaker. The auxiliary contact from the main drive circuit breaker has to be normally open, okay, then used in this arrangement. And then that's off the plate, off the table. So there we have, and then I don't know, do I need 1 0 or 2 zeros? Anyway, so there we have it. Then going down in the control circuit, we have the 3-position selector switch, the multi-position selector switch, 3-position, normal, off, and test. So what are we going to call this? What are we going to call U? Okay, so loop pump. loop. Okay, normal select. Do we start with normal select? Normal select. So this is a discrete input. So come on. We're going to say lubrication pump, lubrication pump, normal select. Okay, so we're just talking about the multi-position selector switch, this one here. So we're going to assign this address, the memory bit address 10.3, to the lubrication pump normal select. Okay, so LP lubrication pump NS normal select. And then of course let me just drag this down. The next one will be lubrication pump off select. So lubrication pump off select. Then the other one will be lubrication pump test select, like so. And then what else? So that takes care of the multi-position selector switch, 3-position selector switch. So LPNS, LPOS, LPTS. Okay, so that takes care of this 3-position selector switch. And then going down, you notice that these are conditional. 284 is as an auxiliary contact of a relay. Okay, so within this schematic, we've got 284, which we've already looked at. If you, in case you've forgotten, 284 is here. It's an output coil. Okay, in actual fact, it's the coil for the main drive. Is it? Let's see, 284. So test relay. Okay, for the test mode, you energize 284. So it's basically a control relay. So we're not going to worry about 284. We're not going to worry about 3BD5 or rather 3BD2, because 3BD2 is associated with this timer. And then the only other input is the test mode loop pump motor. Okay, so that as an input. So we're going to say test, rather loop pump test push button. Okay, so we're going to say lubrication pump test push button, like so. Okay, so that takes care of this this push button here. Okay, so we've taken care of everything in that position. So moving forward, what do we have here? This is conditional. It's related. This is an auxiliary contact for this relay. Okay, and then 4DC1 being the coil of an actual physical relay has got auxiliary contacts, and that normally open auxiliary contact is used in this position. So we're not concerned with this one here. And then what do we have here? What we have here is a fault reset. Okay, so as opposed to having discrete fault reset push buttons for the whole system, for each individual drive, like the crusher main drive fault reset, the vibrators fault reset, the hydroset fault reset, we're just going to have one main system reset. Okay, so we're just going to say, system. Oh, come on. We're going to say system fault reset. Okay, maybe usually you'd find that we do not get the opportunity to put spaces in this actual semantic symbol table. Okay, so I'm just going to put this dash thing, system fault reset, and then of course self-explanatory, no need for a comment. Okay, And then the other thing we haven't dealt with the thermal overload, and we haven't dealt with the earth fault relay for the main drive, or rather for the lubrication pump motor. Now these you'd find in a power circuit much like this one. Okay, like if there was, except in this one schematic, there's no power circuit for the lubrication pump, but it would look something like this, where you have the circuit breaker, and then you have the earth leakage relay, and then you've got the power contactor for the drive. So this is more like a generic arrangement. So that said, it's the same way that you'd have the overload and then you have the earth leakage. These are going to be more or less about protection. So we'll come here. Okay, so we are going to have 4DE3, 4DE3, and then we're going to have 4DE2. We're going to have 4DE2, or if I wanted, I could have just done this 2, then drag down like this. Okay, so we have 4DE2, and then we've got 4DE3, and then of course addresses. We will continue with these. The data type is Boolean. 4DE2 is a lubrication pump. Lubrication pump earth leakage. Okay, so earth leakage, you can go like protection if you want. And then 4DE3 is lubrication pump thermal overload. Okay, lubrication pump thermal overload. Okay, thermal overload protection. So that takes care of this one here. 4DE3 takes care of 4DE2, and 4DD1 is a sealing contact for 4DD1. So now we move to the crusher main drive control. Same vibe. We start with, you've guessed right, the output coils. Righty. Okay, but in as much as it says crusher main drive here, okay, in as much as it says crusher main drive, we have to bear in mind that part of this schematic is actually a continuation of the lubrication schematic. Okay, like up to this part. This part on the left is still talking about the lubrication system, because you see here loop oil temperature high indicator, loop oil flow stopped indicator, loop oil flow interlock, loop oil filter blocked. So for this left section, for this one here, okay, we're still going to continue with the addresses for the lubrication pump. So having said that, we'll have 3BD3. Seeing as how we're talking about the loop oil temperature switch, as a protection input. So loop oil temperature switch, how do we proceed with this? Okay, let's first deal with this output coil, or this relay, 3BD3. 3BD3, we'll continue with this one here as a discrete output. So we'll come here and set, we're saying this is what, 3BD3. Of course the addresses will be just like this, and then the symbolic comment, we're going to say lubrication oil temperature, lubrication oil temperature high. So what's the normal state of this little baby here? So we're using this as a normally closed contact, so meaning 3BD3 is supposed to be constantly energized. So let's see, how have we used 3BD3 in position 4, 20 and 29. Position 4 was 3BD3, okay, because 3BD3 is supposed to be constantly energized, which supports this. And then we're talking about position 20, which is here. So clearly, lubrication or temperature high indicator, if this is constantly energized, then this is constantly open under normal temperature condition. Okay, so this is basically just the lube oil temperature high. So we're okay with this, okay? 3BD3 lube oil temperature high, we're here. And then the other output is the lube oil temperature high indication, okay? So we're going to insert here. So what do we do? Lube oil temperature high indication. Lube oil temperature high indication is 3BH1. So 3BH1, drag down like so. Lube oil temperature high indication. Lube oil temperature high indication. So it takes care of this one, right? And then we're talking about 3BD4, okay? Because we're talking about lube oil, talking about lube oil flow switch, lube oil flow switch, lube oil flow switch. So clearly this is the flow, okay? So let's see. So we insert, then we're going to call this as 3BD4, okay? So 3BD4, what do we call you? So lube oil flow, lubrication oil flow, lubrication oil flow, okay? So basically this relay is just a confirmation of the flow, because once the flow switches are actuated by way of the normally open contacts, so there will be flow in the system, and then as a consequence of that flow going past the flow switches, and then of course we've used the normally open contacts, this is going to close, this is going to close, and then 3BD4 will be an indication of the flow, that there's actually flow in the system. And then in the next run, we're using what? What do we have here? 3BD4. Let's not worry about 3BD4. Okay, so the next run, we're talking about the lube oil flow stopped. Okay, we're talking about the lube oil flow stopped indicator, which is 3BH2. Okay, so 3BH2. Maybe let's just insert a lot of these. 3BH2. 3BH2 is lube oil flow stopped indicator. Okay, so lube oil flow stopped indicator. Okay, so we have the lube oil flow stopped indicator as 3BH2, and then the other output core is lube oil flow interlock. Okay, so this is going to be 3BH5. Okay, this is going to be 3BH5. 3BH5 is the lube oil flow interlock. So what do we have to say for ourselves? Lubrication oil flow interlock. Okay, lubrication oil flow interlock, which is 3BD5. And then of course what we have lube oil filter blocked. Okay, we've got the lube oil filter blocked as 3BH3. So 3BH3, so that's 3BH3. Lubrication oil filter blocked. Lubrication oil filter. Lubrication oil filter blocked. okay, as 3BH3, which is this one here, okay. Then thereafter we've got 281 as the main drive control, okay. So we come here, this is going to be 280, 280, come on, it's going to be 281. Okay, no, we're not really supposed to do this first. Let's get rid of one teeny thing, because I'm just now going to cross over to the main drive. I don't want to do that just yet. So let's look at the inputs, okay, the associated inputs for the lubrication oil pump control, okay. So in the first rung, or rather in this rung, designation 19, you notice that there's such a thing as the loop oil temperature switch. The loop oil temperature switch should be a protection input. So the protection inputs were assigned to memory bit address 20, okay. So loop oil temperature switch. Now, to help us along, because there are no designated addresses, but if you remember, we did have something here. We did have this right here, where we talked about the temperature probe, and then we said anything with a -02 is normally closed, okay. So what we'll do is we'll make reference to the PI process and instrumentation diagram, okay, and then just say T01-02, and then we'll say lubrication oil temperature, okay, lubrication oil temperature, because we're making reference to what we did in the piping and instrumentation diagram. So we're getting the normally closed contact T01-02. The reason why there's a T01, I'm assuming this is just one of several temperature probes in the system. So the designation for this one, as it relates to the lubrication oil temperature, is just T01. As a probe T01, of course, it goes without saying, we're also making reference to the associated temperature controller, which has the necessary auxiliary contacts, okay. So we've taken care of this one here, okay. And then in rung 21, we have loop oil flow switch, this loop oil flow switch, and then we have this other loop oil flow switch. So again, we make reference to the diagram here, the piping and instrumentation diagram. Remember that we had things like, okay, let's do it like this. We had this, okay, when there's no flow, the associated flow 01-01 was normally open, flow 02-01 was also normally open. So what we do here is we'll just say flow 01-01. Okay, let me borrow this, let me borrow that. But this is going to be 21.0, and then lubrication flow switch 1, then the other one will be lubrication oil, okay, maybe let's just say oil, so that we know which flow we are talking about. So lubrication oil flow switch 1, lubrication oil flow switch 2, as it relates to this, okay. Maybe I also want this to be 1, because like I said, the attachment -01 designates a normally open contact, -0 flow switch 2, okay, flow 02-01, meaning we're making reference to the normally open contact. So which is why I've done them like this, okay. That's why I've done them like this. So this one here is this one here. This one here is this one right there. Okay, so that takes care of this floor switch, and then it takes care of this floor switch. Okay, and then going forward to the rung 24, what do we have? Or ladder rung 24, rung 24, whichever. So we've got the loop or failure relay. This is basically just a reset, because if this latches through, this is 3BD5, this is a ceiling contact, and then this is basically just a reset. Okay, this loop or failure relay is basically just a reset for the loop or flow interlock condition 3BD5. So we already have a system fault reset, this one here. Okay, we already have this, so we're not going to be needing this input. What else do we have? Loop or filter bypass switch. Okay, so what are we going to say about this? Because we've got the loop or filter blocked as 3BH3. We already have 3BH3 loop or filter blocked. Now we're talking about the protection input. Okay, this one. Okay, I think you'd understand. I'm referring to it as a protection input in the sense that the loop or filter switch, the bypass switch, is never supposed to be in a position where it changes the state of its inputs, because then you'd know that these filters are blocked. Okay, you know that these filters are blocked. So loop or filter bypass, meaning you're talking about this path across the McDowell flow switch. Okay, blocked filter flow switch, McDowell. This is just a model of this switch. Okay, and then because in relation to this we're using a normally open contact, and then of course we're going to say MC02-01 McDowell flow switch, if this was the only one, because there's also another one here, but we'll just pick one, we'll just work with one. So MC MC01, okay, MC01-01, okay, and then this is they're calling it one, oil filter blocked, or what have they said in here? Oil filter bypass switch. Okay, oil filter bypass, that's the oil filter bypass switch. Okay, so this relates to this. Okay, they're calling it a McDowell flow switch. It's just a model. You can have any number of flow switch models, but in this particular case, Valela and Dapadi McDowell flow switch. So if we took the initiative of assigning addresses or assigning electrical contacts to the piping and instrumentation diagram, which is what we are now replacing umonsom. So like this number nishi yapwamo lubrication schematic. So now we can move on to the main drive. Okay, we can move on to the main drive. So we start with the output coils. So output coils will continue from here. Okay, so the first one is 281. So I know some boring stuff, but it has to be done. Okay, so lubrication 281 is main drive. Okay, main drive, this is the main drive control, that's 281. Then 284, do I have 282, do I have 283, do I have 280? So 281, 2, 3 and 4. Maybe I just need to take the initiative because this is going to be really tiresome. So we just drag this one. Oh, what am I doing? Trip. Are you drunk or something? You must be drunk. You must be drunk, my friend. Like so. And then of course I'm just going to drag this down. So might as well do the same thing to these addresses, because we've got 282 vibrator control interlock. Okay, so the 282 is the vibrator. It's a vibrator control interlock. Okay, 282 as a vibrator control interlock, and then what else? 283 as the main drive. Main drive fault. Okay, so what did we say for the other one? Main drive status, lubrication pump status. Okay, lubrication pump status faulted or healthy. So maybe let's borrow this, and then let's do that. Main drive status faulted or healthy. Okay, so which is 283, and then 284 is the test. Okay, is the test relay. Okay, 284 is main drive test mode. Okay, we'll just call it test mode. Why? Because to energize this this relay here, okay, I'm just going to use these terms loosely. I may just call this as a relay, but it's in actual fact it's a coil, and the coil is associated with a relay. So you are trying to control the associated relay of this coil. Okay, so this relay is going to be energized, and that only happens in the test mode. So which is why I'm just going to call it as a main drive test mode. And then we've dealt with 281, we've dealt with 282, we've dealt with 283, and then we've also dealt with 284. So the other one is 2AH1. Okay, so 2AH1 is going to be fault trip indication. Okay, main drive, I want to do that. Main drive faulted indication. Okay, main drive faulted indication, that's 2H1. Then going forward, we've got the heater on. Okay, as an output, what do we say about you? We're just going to call you heater on. Okay, just going to call you heater on. And then what else is there? Because crusher running. Okay, so as an output, designation 2 H2, and then of course addresses like so. And then we'll say main drive, so main drive or crusher running. Okay, so maybe let's just stick with what we have been dealt. Okay, so crusher running indication as 2AH2. What's the other coil being controlled? 2AC2. 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 Okay, no harm. So we have 2AC2. Is it a small c? Okay, 2AC2 as what? What are you? To AC2 as okay, we can just as well think of this power contactor as having auxiliary relays, because I don't see where this is used in this part, because there's no associated use point. Okay, because you might as well use it as a feedback relay if you wanted, just to increase the number of auxiliary contacts of 2AC1. So I think this is just about it. Then the other thing we may need to find interesting is the use of the thermistor relay, okay, TR. TR is used in this position, so clearly showing that TR is always supposed to be closed under normal conditions. Okay, so this auxiliary contact is supposed to be closed when the temperature of the main drive motor is healthy. The associated contacts of this unit is supposed to be closed under normal temperature conditions. So to fulfill our logic, you can think of this as a protection condition. Okay, so we'll go back to this point as an input. So we're just going to say TR dash 01, clearly pointing to the fact that the thermistor relay, we're interested in the normally what? We're interested in the normally open condition. So how do we swing this? We're saying that under normal temperature conditions supposed to be closed. Okay, so we're going to run through a normally closed contact in this regard. So maybe we go to 02, and then so main drive thermistor relay. Okay, the understanding is that if this thermistor relay is an actual physical unit, we're going to use the normally closed contact of this relay. Okay, so that under normal conditions this will be just normally closed, so we have that signal showing up at the PLC. Okay, but under faulted conditions it's going to open, and then you're going to lose that state. So that's how we've dealt with TR. Okay, so now let's look at the defining input conditions. We've already dealt with the auxiliary contact of the main drive when we talked about MC01, which is this one here, main drive circuit breaker normally open auxiliary contact, which is this point. It's still the same point here. Okay, and then protection H5A 2A1. Okay, I know this may look a little bit confusing, but the simplest way of looking at this is like this. Okay, effectively we're just talking about overcurrent protection. Okay, and then we're also talking about earth leakage protection. So what we'll do is this protection. We're going to run through the normally closed contacts of this P&B code H5A relay, meaning we're using its normally closed inputs or auxiliary contacts. So this is a physical relay, and we're using its normally closed contacts as it relates to H5A and 2AE1, even though, okay, anyway, let's not overcomplicate things. So that's the thing we need to identify, that on this P&B code H5A relay, we're going to use the normally closed contacts, protection contacts related to overcurrent and earth fault. So we just need to assign the addresses. So we're going to go like H5A, these are protection inputs. So we go to crusher main drive, rather main drive, overcurrent, okay, overcurrent protection, okay, and then 2AE1, let me just do this, will be the main drive earth leakage, or maybe let's just say earth fault protection, okay, earth fault protection. So that takes care of these two, okay. We've already taken care of TR as it relates to this position here, and then 3BD3 is conditional, so is 3BD6, so is 3BD4, and then so is 3BD1, so is 284. So which only leaves the 3 position selector switch. So just for the sake of uniformity, we've already dealt with the 3 position selector switch, or the multi-position selector switch. So we did these right about here. Main drive test. Okay, maybe let's copy all of these, and then let's paste them right about there. But now we're talking about the main drive, so MD, talking about MD, talking about MD, talking about MD, okay. And then of course, where the addresses are concerned, what do we have? We have this up until there, and then okay, let me just borrow this, except now this is 22.0, and then of course this is going to be like so. We're going to do it like so. This is how we roll, okay. So we've dealt with the 3 position selector switch, or the multi-position selector switch, as easily as that, because we're trying to maintain the sense of uniformity in naming. So which is why we've just done it like this. So main drive normal select, main drive off select, main drive test select, main drive test push button. No, except for you are not supposed to be allocated this address. You're wrong, and you guys are not protection inputs, but you're just ordinary pausers, okay. You're just ordinary pausers. You're not part of the protection crew, okay. You're certainly not part of the protection system. You're not. You're just pausers. So what do we do to pausers? What do we do to pausers? We expose them for who they really are. Except the thing I'm not seeing. Okay. If you notice, the main drive has this main drive, crusher main drive, has got no system reset, in the sense that this relay, okay, if you have a fault as a result of either overcurrent or earth fault, these you need to manually reset the relay, the P&B goes relay. You need to have to reset it, and so do you have to do the same thing for the thermistor relay. Okay, so we'll see how to manipulate this properly, but I think this basically covers all there is for mapping the inputs, in as far as the main drive is concerned, in as far as the lubrication pump is concerned. These are all the inputs we need. So let's just get rid of the spaces, and then let's save and accept responsibility for our action. Then let's, okay, you're going to ask me again, do you want to save the changes you have made to plant? Yes, I want to save. And of course I need to save this, I need to override, yes, close, and then of course that is done. So now we're going to come back into the schematic interface, open the symbols list again, and then we're going to do what we should have done. So maybe first let's get rid of this, and then we're going to import the same symbol table. Okay, so we're going to import, I think that's on the desktop. It's on the desktop. Okay, this is this one here. I'm going to open it, and undo is no longer possible after this action, and the comment will be applied from the import file for identical symbols. Do you want to continue? Of course, yes. So we're being told import event, there's 0 error, 0 warnings, 0 conflicts. Do you want to open the protocol file? Yes, please. So what do we have? We're being told now there are no errors, there are no warnings, there are no conflicts, which is what we want. So close this, and there you have it. Okay. So as opposed to editing the list within the step 7 project file or within Siemens itself, we export the file to Excel, then do the edit from there, then import it. Okay, so basically this is just what I wanted to show you. So now we have defined all the inputs, we've defined all the outputs, unless of course we've missed something, but from what I've seen, we've covered basically everything. So next we'll go on to create the logic. So tukabona now when we get around to that. Cheers. Cheerio.